Welcome back to Untitled Chapter channel. Today we are going to learn about exponents and powers in chapter 2. So please take notes of this and open your textbook down on your page of chapter 12, in which we are going to learn about the exponents and powers. Sometimes the number here, like how we have sometimes we may have this number 12 to the power 4, for example. If you have some numbers like this, let me see, some numbers may be like this, 12 to the power 4. 12 to the power 4 means here in this number 12 is called the base and its power 4 is called exponents or power. You understand that so far? Then here I have some points to remember. If the exponent is negative, it can be made positive by taking its multiplicative inverse. Here we have some numbers having its exponents as a negative number. Here 17 to the power minus 4 can be made into 1 by 17 to the power 4. So whenever you invert the position of the numbers, 17 by 1 become 1 by 17, then the power minus will become plus. So if like this is coming 19 to the power 3 divided by 16 to the power 2, that means in order to make it positive in exponents, that you have to take the multiplicative inverse, that is 16 by 19, then the power will become positive. Can you remember? In chapter 12 exponents and powers kalau ke ula in le khabu khan ti chuan hei kan han muang hian 12 to the power 4 ang si te hi lo ni ta se ta hen kan hil fia ta 12 zong kha a base and da 4 kha exponents mo power mo kan ti thin ta ni ti khan a chiang ang chu tro chuan a exponents kan ti a power hi negative minus sign pu ni chuan plus sign pu ti mai ang positive a siam tur chuan kha number kha a base kha a let ling zong in kan da ngai ni hey po 17 by 1 alone ta 17 by 1 to the power 4 alone ta chu minus 4 hi positive 4 kan thak 1 by 17 in kan thak ang hey out dot 0.0 ti chiang khopa 19 to the power minus 3 by 16 to the power minus 2 kha a power hi positive kan thak don chuan hey anom na hi kan thak hang ti rang 16 to the power 2 19 to the power 3 it's a thiam tru. Then we'll go to another point. Any negative number having even exponent is always positive, and any negative number having odd exponents give negative results. A base, okay, a base is negative here, minus 2, and the exponents is even number, that is 4. Even numbers are 2, 4, 6, 8, 10, like that, which is divisible by 2. Then the power is even number. Even the base is negative, if the exponents is even number, the result which is calculated out is becoming positive. And if the base is negative and the exponents is odd number, the result will always negative. Le kan tiang khan ma kan tiang khan a base is negative lo ni ta se a power hi even number 2, 4, 6, 8, 10 ang si mo khateng number kop kimang kha ani chuan a result helai a answer chu ka hi a positive zel tur ani a base hi negative ani a power hi odd number ani chuan a result helai kan cho hi minus sign pu negative kan ti zel tur khani. Okay, let's go to the laws of exponents. The laws of exponents, number 1 is a to the power m into a to the power n. If the base are similar and the power is different, if you multiply both numbers, you take the base as a common here, a, and the power you have to add it. That is how we are going to do the problem. For example, 7 to the power 2 and into 7 to the power 5 means both are having 7 as a base and their exponents are different. So as a result, we can keep the base 7 and add up the exponents. 2 plus 5, 7. That means 7 to the power 7. Okay. In the same way, the base, same base, but the power difference is divided, or am by an. That means you take the base as a common and the exponents have to be subtracted from the first to the second. That means the answer will always be, the base will always be the same. For example, here 7 to the power 5 into divided by 7 to the power 2 means 7 to the power 5 minus 2 equal to 7 to the power 3. In fact, loss of exponent pakhat na chuan a base in ana power in an lo khan multiply ani box hi chuan a base ka pakhat kan langa common ang rengin chuan a power te kha kan bel don ani chu. Example han chiang khop maya 7 to the power 2 le 7 to the power 5 hey a base in anga a base ka pakhat kan langa a power te kan belanga 5 plus 2 chu 7 ania 7 to the power 7 ani le mai tin chia khan a base in ana power in an lowa divide ani thung chuan a power te kha minus 2 ran thung ta ni hey example khana chiang vek tru. Then come to question number point number 3. If the base is single a and the power is double, a to the power m to the power n, that means you take a and the power have to be multiplied, a to the power m into n, that means a to the power mn. For example, suppose you have 7 to the power 3 to the power 2, that means the power have to be multiplied. 7 to the power 3 2s are 6, 7 to the power 6 is the answer. Then question number 4, if the base is different and the exponents are same and the numbers have to be multiplied, that means you have to multiply the base first and the answer will carry that same exponents m, that means ab to the power m. Here in the example it is so clear that 7 to the power 3 a to the power 3 means 7 into a to the power 3, that is 7 8 is 56 to the power 3. Okay, le kan sei tong khan heta hen pathum na hian a power here double a chhonga ron kal chuan a to the power m n an chuan hey a power te kha puntir tu ni a to the power m into n, a to the power m n kha answer ni maya. Example hen chiang khop maya 7 hi a power hi chhong ta 3 le 2 nei chhong ta kha a power ha multiply mai tu ran 7 to the power 6 mo kha ten khan tin palina chuan a base in an lowa a exponent in an ve thung khan multiply ani in a base te kan multiply anga a chhok khan a power kha keng telang chu ting chuan 7 to the power 3 le 8 to the power 3 puntir tun ta se 7 le 8 k puntir to panga 3 to the power 3 kha 3 kha alo la kal char charang pasari 100 songa paruk chuan a power 3 kha alaron kengang. Then in point number 5, a to the power m divided by b to the power m. Suppose if it is divided and the base is different, that means you have to divide the base and both the numerator and denominator will carry the same exponents. That is point number 5. And question in the example here we have 15 to the power 3 by 5 to the power 3 equal to 15 by 5 to the power 3. That means with 5 15 is 3 times 3 to the power 3. That is the answer. And lastly to the point number 6, any number, whether it is so small or any number which is very very large in numbers, also if it carries 0 as an exponent, the answer is always 1. Here a very big number is having a power 0 that its real values is 1. Now we'll go to the exercise 12.1. Exercise 12.1 number 1, evaluate. 3 to the power minus 2 is given. As we have learned in the points to remember, here in order to make it positive we have to take the multiplicative inverse of 3, that is 1 by 3 to the power 2, that its value is 1 by 3 square is 9. 3 3s are 9, no? In the same way here, minus 4 to the power minus 2 is 1 by. If the base is negative, you have not to change it when it changes a multiplicative inverse. Okay, 1 by minus 4 to the power 2. That means 1. Then minus 4 square is 16. Okay, here the exponents is even number, so the result is positive, as we have studied before here. No, then instead number 3, 1 by 2 to the power minus 5. That is 1 by 2, multiplicative inverse is 2 by 1. So if the denominator 1 is there, no need to write it. So 2 to the power 5, that means 32. Kan sa tiamang tiro heta hen a power minus ka plus kan santil no chon letling ang kan zia ka chon a hlut na kan latani mitam tak chon 3 square hi 3 to the power 2 po ati thei thawanga kha anin taka chon 3 2 zar 10 3 2 zar 6 10 3 na ma se 3 square om je chu 3 3 zar ti to ni 3 voi ni om ti na ni 3 into 3 ti na ni 9 o khating te khan heta po ani vek ta a ka kan soi fi khain sa thiam tlang chumo. Then we'll go to question number 2, and this question number 2 have simplify and express the results in power notation with positive exponents. So we have to simplify by using the laws of exponents that we have learned before the chapter, before the exercise. We have to make it into positive exponents. So minus 4 to the power 5 divided by minus 4 to the power 8. So that means the base is same, minus 4. So since it is divide, 5 minus 8 it will become. That means minus 4 to the power minus 3. 8 minus 5 is 3, but the larger number carries minus sign, so we can keep minus here. So that means in order to make it positive here, 1 by minus 4 will take its place. Then the exponents will become positive. Okay. Here in question number 2, sum number 2, we have 1 by 2 to the power 3 to the power 2. That means 1 by 2 to the power 3 2s are 6, like that. Here also minus 3 to the power 4 into 5 by 3 to the power 4. That means 3 to the power 4, since the exponents is even, so we can keep the minus sign as positive here. Minus 3 to the power 4 into here 5 to the power 4 by 3 to the power 4. We have separated it. So 3 to the power 4 and 3 to the power 4 are cancelled, so the answer is 5 to the power 4. In question number 4, 3 to the power 7 divided by 3 to the power minus 10, that into 3 to the power minus 5. So we can make everything as positive exponents. 1 by 3 to the power 7, divided by 1 by 3 to the power 10 into 1 by 3 to the power minus, into 1 by 3 to the power 5. Okay, so the answer will be written like this: 1 by 3 to the power 7. Divide, when it changes divide into multiplication, this will change its place. So 3 to the power 10 by 1. So 1 by 3 to the power 5 is still remaining. So we have cancel it. Here 3 to the power 7 is there. Here 3 to the power 10. 10 minus 7 is 3, no? So here 5 minus 3 will become 2. So 1 by 3 to the power 2 will be the answer. Oh, helai kan say feel along. Oh, hey he kan chokanga a power kamay na salon ni hlau chun plus positive at santir tunta. Hey henga te po hian a power khat divide ani vai kan minus ta hen minus 3 khara ta tat maya a power khat positive tur chun a let linga kan dangaya minus 4 po 1 by minus 4 in khating zel kha kan ti ngai ta 1 by 2 by 2 to the power 3 to the power 2 po khating thau kha ni khating vek khan helai tha hi chu kan ti vek anga helai hi tlem na danglam dewa in lo hriat lo takin hey 1 by 3 to the power 7 an ta tro chon 1 by 3 to the power 10 kha positive in kan siam vek ta kan letlinga chon helai hi 1 by 3 to the power 7 ta helai divide hi multiply thak chon hei hi ain let a dot chem hi in letling halanga 3 to the power 10 by 1 anga by 1 kha zel la ngai lo ta ni chu ti chuan he divide cho te tang kha kan kalti ranga helai 3 hlir pasari om hian helai 3 hlir som om zinga mi pasari han chok chianga pathuma la chuangang chuan heta hin 3 to the power 3 anga lo nia helai 3 to the power 3 khan helai anoi mi hi zuk chok te lenga panga tangin pathumi pai chon pahni la chuangang chuan anoya ala omanga 1 by 3 to the power 2 ang niang khaten khan a cho dang hachuin ang thavek ta ni chu chuan question number 3 a hian find the value of ati heta jon a hlutna tak tak kan chu chuangai to ta okay we need to find out the value of these equations. That means 3 to the power 0 plus 4 to the power minus 1 into 2 to the power 2. Here any number to the power 0 is 1 always, so here as 3 to the power 0 is 1 plus, in order to make this into a positive exponents, you can write 1 by 4. Since the power is going to be 1, no need to write it. So into 2 square is 4. So taking an LCM here, we have 4 as an LCM. So 4 into 1 is 4 plus 1. 4 plus 1 into 4. That means 4 plus 1 is 5 by 4 into 4. 4 and 4 can be cut down and only 5 will be the answer. Just like that in question number 2 also, 2 to the power minus 1 into 4 to the power minus 1 divided by 2 to the power minus 2. So in order to make these things into positive power, so we can write this as 1 by 2 into 1 by 4 divided by 1 by 2 square equal to 1 is 1, 2 4s are 8 into here this divide sign will become multiplication, then this will become 2 squared by 1, that is 4. So you simplify it with 4, this is 2 times, so the answer will be 1 by 2. Everything still remain the same here. Then number 4, evaluate. Here we have to find the value of. Evaluate means find the value. It's the same thing like before. 8 to the power minus 1 into 5 to the power 3 by 2 to the power minus 4 here. In order to make this negative exponents into positive, here we have taken 2 to the power minus 4 in the numerator and 8 to the power minus 1 to the denominator. 2 to the power 4 into 5 to the power 3 by 8. 2 to the power 4 is 16, 5 to the power 3 is 125 by 8. So simplify it. With 8, 16 is 2 times. So 2 into 125 is 250. Just like that. In sub number 2 also, 5 to the power minus 1 into 2 to the minus so everything we have made into positive. 1 by 5, 1 by 2, 1 by 6 altogether. 1 into 1 into 1 is 1 always. 5 2s are 10, 10 6 are 60, like that. In question number 5 here, find the value of m for which 5m divided by 5 to the power minus 3 is equal to 5 to the power 5. So we have taken that equation as it is, and 5, since the base are the same here, base are same, and the power is different, so we have to subtract 5 to the power m minus 3. So m minus 3. So this minus double will become positive. Neglecting the base, we have here, since the base are the same everywhere, so we neglect the base. We have only the power here, m minus into minus plus, m plus 3 equal to 5. Here power is 5, okay. So m equal to 5 minus 3 equal to 2. So the power is m is equal to 2. In number 6 here we have evaluate again. 1 by 3 to the power minus 1 minus 1 by 4 to the power minus 1 to the whole to the power whole power minus 1, whole thing power minus 1, okay. So 1 by 3 will become 3 by 1. No need to write 1 as the denominator. Minus 4, 3 minus 4 to the power minus 1. That means minus 1 to the power minus 1. That is minus 1 always. In sum number 2, 5 by 8 to the power minus 7 into 8 by 5 to the power minus. So in order to make these things into positive exponents, we have to take their multiplicative inverse. Then 5 by 8 will become 8 by 5 to the power 7 into 8 by 5 will become 5 by 8 here to the power 3 to the power 4. So make it into the simplification here. 8 to the power 7 by 5 to the power 7 into 5 to the power 4 by 8 to the power 4. With 8 to the power 4, if you cut 8 to the power 4 from here, you will have only 8 to the power 3. Helai 8 pali khan 8 pasari zinga pali han thai chia pathumala chuang hai 8 to the power 3 mo. Then 5 to the power 4, cancel out 5 to the power 4 from this 5 to the power 7, you will have 5 to the power 3. Helai pangal hir pali tang her pangal hir pasari zinga pali kha zu katla pathumala chuang nga chu 5 to the power 3 chun le mai. Then 8 to the power 3 is always 512. Then 5 to the power 3 is 125. Question number 7 also have the same thing here. 25 into t to the power minus 4. Yeah, all these negative exponents, you change their position as numerator or denominator here. Make it into 25 will become 25. Then this 5 to the power minus 3 will go up to the numerator and make it positive, 5 to the power 3. And this t to the power minus 8 will go up to the numerator and its power will become positive. And this 10 is still here at the denominator. And this t minus 4 will take down to the denominator in order to make it positive. And that is equal to 5 into 125 into t to the power 4 by 10. Yes. Actually, with 5 this is 2 times. With 5 this is 5 times. So 5 into 5 into 5 into 5 is 125 into here 40 will cut down 40 from here and left out 40, another 40 here. Then we have 5 into 125 is 625. T to the power 4. Then as a denominator we still have 2. Yes, everything is like that. You just see and try to do it by yourself. In exercise 12.2, I would like to explain this one. Hey, lo and sin ro o number tam tham tak tak khom ta ni. Question number 1 akhan a question kha textbook ami khalo en lok mero o ti hian om ta 0. Itung paruk pakwa som pakhat then 85. Heti hian lo om ta ni hei hi a power notation method unusual method in kan tianga hei hian a tluk chu ni na taka chuan mo hei hian a tluk chu en sinang o helai 0 ni lo number om chun hi en sinang 0 ni lo number om chun hi kan enanga chuan 85 a hian 85 a hian a number pa ngai pakhat kan la telanga chuan tian 8.5 in kan zia kang 85 ki 8.5 in kan zia kanga ti chuan no 8.5 in kan zia kanga chu tiang kan tiang into kan tianga 10 kan da to panga ti chuan 10 kan da to panga 0 kha kan share lon ni 0 hi share ang i a question a khan le lo kala question a khan helai hian 8 zo chia hian 8 zo chia hian point kan da zelang number pa ngai 0 ni lo number pa ngai pakhat kan la tel zelang kan te kha 8.5 aina kalanga hi mo 8.5 angina kalanga chuan 8 chin malam zong digit hi point nen a inkara digit zati kan chia ranga khat ni thum linga ruk sariret kwa som pahnih lo ta ni som pahnih lo ta a chu number reng 0 a kal chuan hei 0.00 chumi om je chu 1i na te ti na ni 1i a te reng a chun a power hi mai na sani don ani chu 1i a te reng a chun 0 point ang chia ron ka chuan a power kha minus zel tu nia 8 malam pang zong decimal point na in kara khan digit eng sang kan sir kha som panin lo me som pani kan sira chuan a power kha minus tu ran ni buka minus 12 ti kha kan zek nga hei hi answer ani mai mo chuan eng po ni seng adanga po khan en sin taila adot le che po khan sin mai mang in ti tur ka pedon cheu in ti tur kha kan pedon cheu pedon chiang lutuk cheu ole sorry headline en le chinang 0 point Hei thum linga ruk sari ret kwa som bukat 942 heta po hian han chia le taila 942 9 hi kan la tel chi ang kan ti kha point malama mo chumi om se chu 9.2 lonta 9.2 9.42 zokolong 42 9.42 nia into kan ti ta khan 10 kha kan zek le topanga 10 kha por nei turin kan zek le topang chuan 10 tro a por kheng sang hen yang 0 point ani wangin 0 point ani wangin 1i te a englo kha a por kha minus tur ani ti kan chianga 9 na chin 9 chertel chi in decimal point nen kar khen digit engzak nge om han enta ula som pani tholo om liang chuwa chuan ti khan in set thiam to mai karinga ani le 0 point ni lovin a chi dangin engtin nge ti theidan om entirnan sub number 4 no sub number 3 ang te kha engti ti chi nge ni ang hangai to wang chin te ule sub number 3 kha 602 ma 602 en sin lokang 602 0 khain sang e om ka textbook mi che chiang lo khan ti sinang en sin mai nan kan nei thum linga ruk sari riat kwa ti helom ta se hei hian nge tukang hei 0 point ani to reng lo ta 0 point ani lo ta mar chu 6 hi kan la tel chi chiang 6 kan la tel chi chianga 6.02 chuan times kan ti lenga chuan 10 kha kan da lenga 10 kan da lenga hei chu 0 point ani tak lo wangin 10 hi chu da sim tur nei chu a por hi engzang kan endon ani point nung lama pang ta hen point kan da ta ni 6 so chin point kan da ta tru 6 so che point kan da point nung lama hen digit engzang nge om share sinang le khat ni thum linga ruk sari riat kwa som pakhat digit som pakhat om ta chuan 0 point ani lo wangin a por kha positive to turani tikhan ani ta ni chuan sub number kan cholo 4 le 5 kha chin chaw tura da taila chuan number 2 a khan number 2 hian in en le chin lokang o question number 2 kha kan en chin lokanga 12.2 question number 2 kha en le chin lokang question number 2 chuan he tuna helai equal to le lama kan da kha malama kan da khan thak le turtina ni chu thak le chin don ani 3.02 into how many 10 to the power minus 6 more 10 to the power minus 6 alone yeah chu power minus 6 alone ta number heading decimal point omang sian kan thak le don ta ni ti chuan a power hi minus ani miaw wagin a power kha minus ani miaw wang khan ta hian 0 point kan ti halangai ni 0 point kan ti halang chuan helaya 3 hi kan la tel che chenga hei 3 hi kan la tel che 3 chiar tel che in hei 6 ngai poi mo si in mo engti kan tiang khat ni thum li nga arukna khan 3 hi kan siak tel chiang chuan decimal point om to lovin 02 ti khan khi answer chu ni le mai 4.5 into 10 to the power 4 more andot le po khan ensin le taila 4.5 okay let's take 4.5 mo kha adot le kha 4.5 into 10 to the power exactly kha 10 to the power 4 more 10 to the power 4 lo omta 10 to the power 4 ani chuan 10 to the power 4 lo omta chuan ang tingin itang hei chu positive ani tatlat maya positive ani chuan point khi kan ti bo hal photang 45 kan da photang chuan 5 chiar tel che hian 5 chiar tel che hian digit li ani turani digit li 5 chiar tel che chin 5 khi kan chiar tela digit khatna khat ni thum li khi answer ani le mai chuan khan question number 2 kan thiam le ta question number 3 kha han en wang ula question number 3 kha tuna miang thau kha ni tuna miang thau kha number 1 ne nang reng number 1 ne nang reng kha chu number 3 kha chu nang ma ni lo cho tura dang chu number 4 kha ngai lo number 4 kha ka ngai lo wa chuan in test huna in syllabus tur test portion tur chu chapter 8 le chapter 12 ani ang khazung kha kan zir thei ni ro se voina tan chuan lo me